We've shown you a variety of cutters that you may expect to find in a machine shop. Now let's take a look at what those cutters are capable of and the different profiles that they machine. We've installed a fly cutter and we've got a block of aluminum mounted in the vise. We'll show you how quickly and efficiently a fly cutter surfaces a piece of material. Okay, we'll back our fly cutter out until we just are in contact with the work, cast off of it. We're going to take about a 5/1000th pass. Anytime that you're working with aluminum, a really cost-effective lubricant for machining aluminum is Old WD-40. With a very smooth advance of the cutter, we'll start surfacing across our part. Remember how we showed you to advance the mill by rotating the hand wheel in the palm of your hand. Very important for producing a smooth, uniform cut. You can see how smooth the rotation is. Okay, now we'll pause a little bit. We'll show you a jerky rotation, of which you do not want to do. Okay, that'll be evident in the finished cut. All right, you can see that particular part's about 3.5 inches wide, and we can completely surface it in one pass with the fly cutter. If we were to have a 3/8 end mill and try and surface something that wide, we'd be there a week trying to do it. Now let's take a look at a different type of cutter that we can go across to surface or face the end of our block while it is mounted in the vise. Take our 3/4 inch solid carbide center cutting 4-flute end mill. We ran the fly cutter at 660 RPM. We're going to increase the RPM to 1115. Bring the quill down, center our cutter on the part, lock the quill down. This will be a facing operation across the end of our part. We're working in the what axis right now? For those of you that said y-axis, you're correct. We've dial indicated our vise in, so anytime that we work off of the y-axis, the surface that we are machining is absolutely, positively 90 degrees to the x-axis. All right, there's our facing operation that's complete. We've surfaced the top of the plate. We've faced an end of it. Now let's put a little gingerbread on by using our corner rounding end mill. Remember to always choke our cutters up nice and tight, unless we're in a special application that we need the cutter to protrude farther from the collet or the tool holder. Now look closely as we rotate the cutter, and you can see the relief angle right on the end of my finger here. This is the top of the radius in a corner rounding tool. We do not want to cut below that. So we're going to take the corner of our corner rounding end mill, offset it enough, and just bring it down in contact with the top of our workpiece. Next, we're going to move down to the knee, and in the Z-axis, we are going to lower the bed 5/1000ths of an inch, creating a 5/1000ths gap between the top cutting edge of the cutter and our workpiece. Back the tool away from our work and slowly engage it. We're going to need to watch in two directions now as we apply the cutting depth. Okay. Come across in this fashion. Again, give the tool a little shot of WD-40. Acts as a very good lubricant. You can see the very attractive rounded edge that we're applying to our workpiece. Okay, looks pretty sharp. Now let me show you the incorrect way to do that. If we were to cut too deep on the top mode, we're going to raise the bed up just a little bit where we actually start cutting in two directions. We're going to cut a little deep. Okay, you can see where we've cut too deep along the top line here. This makes for a very poor decorative effect, and this is an improper radius. We want to have a nice, smooth, continuous radius that you see here that just flows from the top of the part down to the bottom edge. All right, we'll install one of our AccuPro tool holders, and let's take a look at what a form tool does on the end of our aluminum slab. Make sure we don't have any aluminum chips or debris on our tool holder as we insert it into the spindle. All right, let's take a look at what a form cutter does now. Just like a giant router bit, for those of you that may be woodworkers, our form tool is going to start profiling now our block of aluminum to our finished dimension. We'll give it a little shot of WD-40 there and improve our surface finish. The nice thing about machining aluminum is you can really get a nice surface finish on it. For a final pass in aluminum, I recommend a climb cut. We'll go into that a little bit farther into the series. But you can see the special profile that we've machined now. This particular form tool is for building a special wrench that we do. Let's move our cutter out of the way and see if we can give you just a little bit better view. There you go. How's that look on a close-up? It's a nice concave profile there, like I say, for a special wrench that we do. All right, let's change cutters now and go to a Woodruff cutter. Remember, the Woodruff cutter now has got considerably more teeth than this two-flute cutter, so what are we going to need to do? You guessed it, slow the cutter speed down tremendously. We're going to go ahead and shift the machine into back gear. We'll use a 1/2 inch collet. We're going to turn the Woodruff cutter about 135 RPM in back gear. We're going to put a Woodruff key in something, a shaft or another part. Remember, we index the top in. We go from out to in on our exchange lever, and we turn it in reverse in the back gear mode. Give it a little shot of WD-40. Lower our cutter to our workpiece just a little bit. Let's take a look at the effects of a Woodruff cutter. Okay, now these types of cutters have a tendency to load up. So take them out and clean them from time to time. Give them another shot of lube. You can use your air hose on them. Blow those chips out. All right, let's take a look at what we've done. I'll grab the air hose and I'll show you the proper way to use air on a milling machine. You can have a pressure regulator on the hose line or very gently use our air hose to blow the chips away. Turn your machine off. All right, you can see the beginning of a keyway that we're just starting to machine into the end of the aluminum block using a Woodruff cutter. Now let's go on to bigger and better cutters. Let's go ahead and make a little V-block pass But first, what are the important things that we must remember when we shift from back gear to direct drive? We make the change on top of the headstock, we switch our lever from in to out, and then we take our wrench and turn it until we hear that clunking sound of the gears dropping into mesh again. Otherwise, if we turn it on, we're going to have a terrible crashing gear noise before those gears align themselves. All right, let's use a center cutting 3/8 end mill this time. Remember we talked earlier about a center cutting mill, or a mill that we can plunge with, versus a non-center cutting mill. This is a 4-flute center cutting in the AccuPro tool holder. Okay, anytime that we're going to use the end mill in a plunge mode, we're going to go ahead and plunge using the Z-axis, or by raising the knee, in order to plunge the cutter into the workpiece. We're going to turn it around 1115 RPM for a 3/8 4-flute cutter. Little shot of WD-40. Then we slowly start raising the bed. You can see that it starts to cut immediately. Another shot of lube, plunge to whatever depth we want. Now we're ready to machine our slot. Break through onto the other side, raise the Z-axis, and we'll take a second pass. Taking about 100 thousandths in this particular pass. Got a pretty healthy feed rate. You can see the chips boiling out from around the cutter. Remember we talked earlier about listening to the machine. Hear how smooth the machine is running. It's not going clunkety, clunkety, clunk. That's telling us we're turning at about the right RPM. We've got a feed rate that is consistent with the RPM that we're turning. Anytime the cutter is going clunk, 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 trying to grab or push the work out of the way, it's telling us usually that one, the feed rate is too fast, or the RPM is too slow. We'll take a third pass again, about another 100 thousandths, and then we're ready to try our big dovetail cutter. All right, we've made the last pass using a 3/8 end mill. We can see we've got a lot of chip buildup around our part. Do we want to use our finger to go ahead and wipe those chips off? No way. Grab an acid brush, a toothbrush, use a little bit of air, whatever, but do not, under any circumstances, stick your finger in around the cutter while it's moving. We've developed a pretty sharp edge along the edge of the channel that we've machined there. If you're to run your finger across it, it's going to cut you like a serrated knife. So always use a little acid brush or a rag or towel when you're wiping it off, and be very gentle. All right, now let's throw in our special V-block cutter and see what that profile looks like. V-block cutter has a 3/4 inch shank on it. So what size collet are we going to install? You guessed it, a 3/4 inch collet. Choke the cutter up nice and tight to the top of the collet. Bring it down in contact with our work. We're going to climb cut on this pass. We're going to cut the right-hand side of the slot first. Got an appropriate feed rate. We're taking probably about 20 thousandths off in this initial pass. We'll index over on the other side and take an equal amount off. Shot of WD-40 as a lubricant. You can see how the chips are kind of coming off like brass out of a machine gun. It's another important reason to be wearing your safety glasses at all times. All right, if we were machining a little V-block for a piece of tooling or fixture, we'd be just about complete at this stage of the game. Grab our acid brush, clean it off, and we'll set a cutter in there to show you how it works. All right, if we're going to build a little cutter to hold some round stock, you can see that that V-block works just perfect. We can run a little overarm clamp to the side of it to hold it in place. We can drill and tap it, whatever the case may need. All right, let's see what else we have. Let's go ahead and do some ball end mill work. You'll be called upon to do that from time to time. Remember, radiuses in the corners, just like turning on the lathe, are very important to the strength and structural integrity of the part. So anytime that we can machine a radius into a slot or a groove somewhere, we're simply increasing the strength of that specific part, eliminating the possibility of a fracture or a stress crack if the part's going to be put to hard use somewhere. We're going to go ahead and use our solid carbide 2-flute half-inch ball end mill. Can we plunge with this particular cutter or not? You bet. It's a 2-flute center cutting. We can plunge. We'll show you an example of that in just a second. We'll go ahead and pick up the same path that we did with the V-block cutter. Come down until we spot off. Shot a WD-40. Go ahead and raise the knee. Whatever depth we want there, pull our cutter out. We're now ready to take a pretty heavy cut. Anytime that we're working in one direction on the mill when we're cutting, it's a good idea to go ahead and lock your gibs down in the opposite direction. That way we're not pulling against the lead screws, and it gives us a truer, straighter cut. Okay, we can index our cutter over now for a final pass. We'll go ahead and climb cut in this direction. Clean up both sides. We'll clean it off and show you what a radiused ball end mill profile looks like. Remember, we've got a nice uniform rotation of the hand wheel on the y-axis. Just let it slip through the palm of our hand. Get some of the chips out of the way so you can see a little better, and another shot of WD-40, and we're just about complete. I'll try and give you a close-up view there so you can see that nice slot. All right. That's a pretty good example of the types of profiles and different machining operations that we can do from basic cutters, form cutters, and fly cutters. An important thing to keep in mind is the proper care of the cutter. You can invest a small fortune in cutters. Good end mills are going to run you 15, 16 bucks a piece in the 1/4 and 3/8 diameters. You can spend up to $100 for a good solid carbide 3/4 inch end mill, depending upon where you purchase it. Your corner rounding end mills are also very expensive, $25, $30, depending upon the radius that you're using. So we want to protect these tools. When we set them in our drawer, we don't want to set them together where they're going to, and I'll show you with the set of our R8 collets, they don't want to be clattering and beating themselves together. They've got very sharp, delicate edges on them, and if they clatter together and chip and dull themselves in your toolbox, you're not going to get the maximum performance out of the cutter. You're going to constantly have cutters in the shop for resharpening and grinding, and this is more money out of your pocket rather than in your bank account. So keep the cutters separated. You can make a little wooden block, cut some slots in them so each cutter has its place and it isn't rotating or sliding back and forth in your toolbox. All right, let me remove the block from the vise, clean it off, and let's take a look at some of the cuts that you've just witnessed. The top surface we machined with our fly cutter. You can see in the beginning as I moved my finger across, we had a nice, smooth, uniform rotation of the hand wheel on the bed. When we went to the choppy mode, you can see the big score mark that was left as we rotated the handle down. This is what happens if you're not careful and have a smooth stroke. So keep that hand wheel rotating like a greased ball bearing in the palm of your hand. Next, we have a slot that we machined with the ball end mill. You can see it's a nice deep radius channel. We've got our form cutter profile that we machined on the end. It's a good view of that. We've also got our keyway that we machined with the, you guessed it, Woodruff cutter. Woodruff cutters are used to machine slots and keyways. We've got a nice radius edge that we did with the corner rounding end mill. All right, we've shown you a lot of the different cutting operations using specific profile cutters, Woodruff cutters, end mills, ball mills. Now it's time to move on and take a look at the different types of materials that you may be expected to machine in the shop.